student notices that whenever they listen to a certain type of music while studying, they receive good grades on their exams. The brain might conclude that the music is responsible for the academic success. But the real cause could be something else entirely. Maybe the student only listens to that music when they are already focused. Maybe they study longer during those sessions. Maybe the subjects being studied were easier. The music and the good grades happen together, but that doesn't mean one created the other. This confusion becomes even more powerful when statistics are involved. You might see a headline claiming that people who drink more coffee tend to live longer. The immediate conclusion many readers draw is that coffee must be causing longer lifespans. But correlation alone cannot prove that. Perhaps people who drink coffee also have other habits, like socializing more, maintaining active lifestyles, or belonging to certain socioeconomic groups that influence health outcomes. Without careful analysis, the brain jumps to the simplest story. Coffee causes longevity. In reality, the relationship might be far more complicated. This mistake becomes especially problematic in public discussions, where simplified explanations travel quickly. News reports, social media posts, and casual conversations often present correlations as if they were proven causes. The mind rarely stops to question the difference. Part of the reason this confusion persists is that causal stories feel satisfying. When we believe we understand why something happens, the world feels more predictable and controllable. If a clear cause exists, then outcomes can be influenced. But when events are shaped by many overlapping factors or by randomness itself, the sense of control weakens. The brain prefers certainty over ambiguity, so it constructs causes, even when those causes are incomplete or incorrect. Scientists spend enormous effort trying to separate correlation from causation. They design experiments that isolate variables, compare control groups, and analyze data carefully to determine whether one factor truly influences another. In scientific research, discovering a genuine cause requires far more than observing two things happening together. It requires testing whether changing one variable consistently changes the outcome. But in everyday thinking, most people rely on intuition rather than controlled evidence. When events appear linked, the mind fills in the causal story automatically. This doesn't mean people are irrational. It simply means the brain evolved for speed, not perfect accuracy. Learning to recognize this mental shortcut can change how you interpret information. The next time you hear a claim that one thing caused another, it may be worth asking a few questions. Did these events simply occur together? Could other factors be influencing the outcome?